All right, second example, we're looking at the x-intercepts would be the first thing I would look at. Do you have to write all of this stuff down? Not necessarily, but maybe it will help some of you to write this stuff out. X equals -3. What's the multiplicity? Knowing what the graph looks like at -3 is going to tell me what this multiplicity looks like. Do we go straight through? Do we make a U-turn? Or do we turn and continue go through? We go straight through it. So the multiplicity has to be 1. And we can write that as a factor as x plus 3 to the first power. We don't have to write the 1. We have another x-intercept at -2. We made the U-turn at -2. So if we go back up and look at our multiplicity guide from Friday, we made the U-turn. So that's going to be a multiplicity of 2 or 4 or 6 or 8. We don't know which one, so we're just going to use the smallest number possible. Which would be 2. We're going to use the smallest number possible. Then we have another x-intercept over here, and x equals 1. That has to be an odd number. I know it has to be odd because it crosses the x-axis. It doesn't just touch, but it crosses in a way where we have to turn and continue to go on. We got to turn to go up through it. So the smallest that multiplicity could be is actually 3. So as a factor, that would be x minus 1 to the third power. X minus 1 to the third power. In this case, does the degree have to be even or odd? You can look at the graph and figure that out. Even, because both ends are going up, so we know the degree has to be even. If we add up these multiplicities, they should add up to an even number. 1 plus 2 is 3. 3 plus 3 is 6. So the smallest number that the degree could be is 6. It can't be 5, can't be 4, can't be 3. It could be 6. At least has to be 6. Could be 8. Could be 10. Has to be at least 6. And what about the direction? The direction is just going to give me this idea of the leading coefficient. Both ends of this graph are going up. And since both ends of the graph going up, is the leading coefficient positive or negative? Positive. And since I know the leading coefficient is positive, we can just list the factors being multiplied together. It does not matter what order we put them in. X plus 3, x plus 2 squared, and x minus 1 to the third power. And the number in front is a positive 1. You don't have to write it, but there is a positive 1 right there. We don't have to write it. Does it have to be 1? No, it could be 2, it could be 3, it could be 4, it could be 5. It could be a fraction, as long as it's a positive number. On your quiz and test, they're going to be multiple choice, and it's always going to be 1 if it's a positive number, -1, -1 if it's a negative number. And we do say possible equation because that number in front could be a different number than 1. And also these exponents could be 4 or 5 accordingly, but we don't really know. So we're just going to use the smallest exponent. All right, if we can do that, if we can look at a graph and we can come up with the equation, we should be able to start with the equation and come up with a graph. Should be able to, maybe not, but should be able to. So the degree in this case, we can add up the exponents. 1 plus 1 plus 1 is 3. The number in front is positive. Since the number in front is positive, I know the left side of the graph has to go down and the right side of the graph has to go up. Based on just that idea. Hey, the biggest exponent has to be 3. The leading coefficient is positive. So we know what the ends of the graph are going to do. And that goes back to what we did last week. We know the ends of the graph are going to go opposite direction. Left side's going to go down, right side's going to go up. At this point, we might want to look at the x-intercepts. So if we look at just the x, that's going to be x equals 0. And x equals 0 is going to have a multiplicity of 1. How do I know it's a multiplicity of 1? Because it's x to the first power. What if it was x squared? Multiplicity of 2. X to the third, multiplicity of 3. And we can go ahead and put that on the graph. So let's put x equals 0 on our graph. What about x plus 5? X plus 5 is going to give me an x-intercept of x equals -5. And that is x plus 5 to the first power. So that's still going to have a multiplicity of 1 also. So let's put -5 on our graph. Now these are points where we touch or cross the x-axis. X minus 3, the x-intercept is going to be +3. And this one also has a multiplicity of 1. The most basic graph, all of the multiplicities are equal to 1. And that's what we see here. So we can put that on the graph as well. X equals 3. So once we have the x-intercepts on the graph, we also know what the ends of the graph are doing. We know the right side has to go up. So we're going to find the x-intercept on the far right, whichever one is the one to the furthest right, and we're going to draw the end going up, because that is the end of the graph at this point. And the x-intercept on the far left, we know the left side has to go down. So we're going to draw this side of the graph going down.
And it can only have up to 2 curves, right?
We could have up to 2 turning points. We don't know that. We could only have 1, but we could have at most 2. But if we go back and look at the multiplicities in this case, it's going to kind of take, the turns are kind of got to take care of themselves. We don't really need to worry about the number of turning points at this point. So x equals -5. The multiplicity is 1. So what's going to happen at -5? Are we going to go straight through? Are we going to make a U-turn? Or are we going to turn and continue to go up? Straight through. So I'm just going to draw a line going straight through. And we have to go up and come back down to x equals 0. So how far up do we go? We don't really know that part. We don't really know how far up we're going to go. But what's going to happen at x equals 0? We got to go up and come back down to x equals 0. At x equals 0, the multiplicity is 1. So we're going to go straight through. That's not very good. But we're going to go straight through at x equals 0. And then we got to turn and go back up. And at x equals 3, well, guess what we're going to do? The multiplicity is 1. So we're going to go straight back through.
Will you always just connect the dots?
Yes, we are just connecting the dots based on the multiplicity. Because if this had been a multiplicity of 2, I would have made a U-turn and went back up. But the multiplicity was not 2. The multiplicity was 1. But yes, all the dots are going to be connected based on what the multiplicity looks like. Could this graph had went up a little bit higher and maybe down a little bit lower, or maybe up and down a little bit less? Yes, we don't really know how far up and down the graph go, so I'm not going to be testing you over like how far up and down they go. But notice all of these graphs look very, very, very similar, no matter how far up or down the middle of the graph goes. So I won't be testing you over the middle of the graph. Only the yeah, you get the idea. Just that. So if your graph looks like that, if it goes up a little bit higher, it's okay. I promise. So can we graph these without maybe writing all of this stuff down? And the answer is yes, we could. So I know that we can add up the exponents. We get 2 plus 1 plus 3. That's going to be 6. That's an even number. So we know both ends of the graph have to go opposite direction. I'm sorry. Both ends of the graph have to go the same direction. Which direction are they going to go? Well, it goes back to this negative t, and both ends of the graph are going to go down. So I know a lot about what this graph looks like, and I haven't even crafted it yet. But now that we have the factors, we can find the x-intercepts, and we can draw a much more accurate graph than we were drawing the other day. So let's put the x-intercepts on here. X plus 4, that's going to be -4. I'm not going to write them all down this time. You can if you want to. And if that helps, by all means, write them down. X plus 1 is going to give me an x-intercept of -1. And x minus 2 is going to give me an x-intercept of +2. We okay with that? Now, we're going to find the x-intercepts on the far left and far right. And both of those are going to go down. So from the far left x-intercept, we're going to go down. And from the far right intercept, we're also going to go down. At this point, I would recommend maybe if we're drawing these graphs by hand, maybe draw the ends of the graph very lightly. Because what might happen? Maybe one of them is going to turn and go through, and then it's not going to line up with what you just drew on the graph. So maybe draw very lightly at this point. That way, when you go back and actually draw the real graph, maybe it'll look a little bit nicer. But as long as we can tell what it looks like and what it should be doing, that's okay. So at -4, the exponent is 2. So are we gonna go straight through, U-turn, or curve as we go up through? That's really the only 3 options. Since that exponent is a 2, we're gonna actually make a U-turn. But then we have to go up, we gotta go down and back up to -1. What's gonna happen at -1? We're gonna go straight through, a U-turn, or curve as we go through. Straight through. So we're gonna go down. How far down? I don't really know, but we're gonna go straight back up through at -1. And then we gotta go up. How far up? Don't really know, but we gotta come back down and hit 2 actually, 2. But how are we gonna, what's gonna happen at 2? We're gonna make a U-turn, we're gonna go straight through, or we're gonna kind of turn as we go through. We're gonna kind of turn as we go through. So this is where I would actually erase this part, because if I try to draw the turn, it's not gonna look very good. Because if I try to draw the turn, it's just not gonna look very good. So that's why I said maybe draw lightly when you draw the ends of the graph, so you can go back and erase that point. Or if you draw lightly enough, you may not even have to erase anything. I took a drawing class at Disney World over fall break, and our pencils did not have erasers on them. And our instructor said, hey, guess what? You need to draw very, very lightly to begin with, because we don't have time to erase stuff. And when I got done, you couldn't even really see my first sketches because it was so lightly done that once we actually started filling in what we wanted, you couldn't even really see the parts that we probably should have erased. Yes?
So if that last exponent was like a 5,
If that last exponent was a 5, you would do the exact same thing, yes.